So continuing with lesson 1.1 in college algebra, we are on the second video, 1.1 B as in boy, and we're on page 13, and we're still working on the whole idea of functions. And so the picture that they have about halfway down the page are arrow diagrams, and notice what's happening here. The domain, the independent variable, look at what they're doing. They're saying, okay, 2 will give us 3. Okay, so they're just saying if you have an equation and you put 2 in for, let's say, x, the answer will give you a 3. Put a 5 in, you'll get a 4. Put a -1 in, you'll get a 1. See how each one of these numbers here is mapped to exactly one number here. Okay, now let's look at this one. This says not a function. The 4 goes to one value, 7, but look what happens here at the 8. The 8 maps onto both a 6 and a 9. So that's what makes this not a function, is this 8 has 2 lines drawn from it. The 13 is only to 1. Now let's look at C. C is a little bit different, but notice what happens. 2 gets mapped to 6, 3 gets mapped to 7, 4 gets mapped to 6. So even though 2 and 4 get mapped to the same number, 4 only goes to one number and 2 only goes to one number. So that's okay if they go to the same number. They just can't go from one number to 2 numbers in the range here. Okay, so something to remember. That's one way you can tell through arrow diagrams if it's a function or not. Okay, the next part of this says tests for functions. So we're going to look at a couple easy ways to determine whether or not something is a function. So I'm going to skip example number 3, let you look at that and read through that on your own. I'm going to go down to number 4, where it gives us a couple different things on functions. So first of all, for A, it gives us y squared equals 3x minus 3. And it's saying, does this equation define y as a function of x? Meaning, if I put numbers in for x, am I only going to get one y value for every number that I put in for x? So, for example, let's say that I put in a 4. Let's say I put in a 4 for x. Okay, so I get y squared equals 3 times 4 minus 3. So y squared equals 12 minus 3 is 9. And y, then, we're going to take the square root of both sides, and that gives me a plus or minus. So y, oops, that's a square, equals plus or minus 3. So when x is 4, y is going to be 3, and y is also going to be -3. That means that my y value, I have 2 y values. So I put in a 4, and it's spitting out 2 answers. So that means that it is not a function, because what's happening is my 4 is mapping to a 3, and it's also mapping to a -3, and that makes it not a function. Okay? B, on the other hand, in example 4, y equals -x squared plus 4x, it does not matter what number you put in for x. You're going to square it, take the opposite of it, and add 4 times that number, and you will only get one number. So if I have y equals -x squared plus 4x, and I decide that x is 2, y equals -2 squared plus 4 times 2, I'm going to get 4 for y. Okay, and that will always happen. It does not give you an option for a second value for 2, or for y. It gives you 2 for x, you get 4. You put any other number in there, you're going to get 4. And just something to review over real quick. This right here, this x squared, this negative, is not negative, like we put in a 2, is not -2 times -2 giving you a positive 4. No. The only thing that's squared here is the x, and then the negative is put on after the fact. Okay? The only way that changes is if you are writing it like that. and then it means that the negative and the x are squared, and a negative times a negative gives you a positive. Whereas here, it's not in the parentheses, so only the x is squared, and then you tag the negative onto it. So just a little bit of a review there. And as far as c goes, for example, 4, that also is not a function, and I'm not going to really draw anything, but notice that when you get almost to August 20th, notice that green line, how long it is. That means all the values there between, looks like $32 and $34. Okay, so there's several amounts there that work for that day. Let's just say it's August 18th. So on August 18th, you have values anywhere from 32 to 34. So on August 18th, you get multiple y's, don't you? Okay. You get on the horizontal line, you get August 18th, so one value, and you get many different answers on the y axis that correspond to August 18th. So because you get many y values when you put in one x, therefore it is not a function. Okay, down at the bottom of page 15, we've got a couple different ways to determine whether or not something is a function, and the easiest way is called the vertical line test. The vertical line test means that you have a graph, and let's say, for instance, our graph is like that right there. If we can draw a vertical line anywhere on this graph that goes through the graph that we have right here at more than one place, then it is not a function. Okay, and in this case, that vertical, and it doesn't matter how many vertical lines, as long as there's one that goes through the graph at more than one place, it is not a function. If I have a graph like this, that looks like that. Now if I draw vertical lines, notice each time I draw a vertical line, it only goes through that graph at one point. So that's an easy way just to look at the graph and determine whether or not it's a function. Another way to determine whether or not something is a function, and I don't know that they even went over this in the book, but if you're given a list of coordinates like this, okay, and you have a y value that repeats itself, like here I get a 6 and here I get a 6, that's okay, because I'm mapping a -7 to a 6 and a 3 to a 6. But what would make it not, this whole thing a non-function is if I had a 3, 7. Now notice what I've got here. I've got an x value of 3 and an x value of 3. And this one goes to 6, and this one goes to 7. Okay, so it doesn't matter that I've got a 3 down here and a 3 down here. If my x values repeat themselves, it doesn't matter what the y values are. If my x values, if you see x values that are repeated twice, 3 times, 4 times, that automatically means that it is also not a function. Okay, so just something to look at. X values are they repeat themselves, not a function. So why is that not a function? Well, let's graph these points and see if we can figure that out. There's the first point, second point, third point, -7, 6, -5. Let's change this to just -5, 1, since I'll stay on the graph that way. And then 3, 7. Okay, so if we were to graph this, we've got, what do I do here? Something like that. Now see what happens here? Whenever there is a point directly above another point, that means it's not a graph or a function, because see, 3 is my x value, and what's my y value when I'm at 3? Well, it's both 6 and 7. Both 6 and 7. So what happens, see if we did the vertical line test and I was drawing these lines down, what happens when I'm here? I'd go through 2 points, or really more than 2 points there, wouldn't I? That means it's not a function. So that's what's going on there. So I already mentioned in the last video the whole f of x, which is actually y, or your output value. And so we're going to look at example 5 when they're talking about function notation, and they're saying f of x, or if you like to say y, you can say that, is this here. Okay, so what we've got here is an equation, has an equal sign. If we put in numbers here for x, it's going to give us a y value, or the function of x, meaning if I put a number in here for x, what number am I going to get out? Okay, so A says, use the point shown on the graph to find f, oops, lost my pen there, f of -2 and f of 4. So what that means is all we're going to do is replace our x values with -2, because see, x is -2. Make sure you watch your negatives. I like to put whatever x equals in parentheses like that so that I don't get my negatives goofed up. If I don't put them in parentheses, that could look like 28 minus 2. Okay. It also tells me that not only is 2 cubed, but the -2 is cubed. So that's going to be -8, because -2 times -2 is +4 times -2 is -8. So it just kind of keeps everything clean. Now if we look at the next one, do this in blue, function of 4, or f of 4 times 4 cubed plus 5, and you're just putting, again, I like putting my values in parentheses, and I'm just solving that. Okay, I'm going to cube that, square that, multiply that, multiply that, multiply that, use the order of operations following the procedure, and end up getting the right answer then. And you can look at the top of page 17 and see what the graph were to look like. If you were to put, a 50 bajillion points in there, you'd get that graph. And the next question is that a function? Okay, yes it is, because you can just look at it and realize that the vertical line test, you are not going to go through that graph at more than 1 point. Okay, almost done with this section. Let's look at example 6 here on bottom of page 17. So we've got along here our x values, our years, and then this number here are millions in the workforce of elderly men. Okay, so we've got this is the year, and they also call that, according to the problem, T. So this is T, and and they're calling this G for millions. So this is 50 million. And if we look here, so each year that goes by, or each decade that goes by, we have fewer and fewer elderly, it goes up a little bit, in the workforce. Okay, so the first question is find and interpret G 2020. So that means what is the Y value, or what is the G value in 2020? Well, here's 2020. My G value is 21. That's the number that corresponds with 2020. What is the input T if the output is G of T is 19.6? So now they're saying, I'm going to give you the output. So the output almost always is going to be the Y value. So when is it at 19.6? Right there. So I'm looking for the input. The input would be T, and it would be 2030. All right, let me erase my mess here so we can go on to C and D without this being too confusing here. All right, so C, what can be said about the number of elderly men in the work period during the period 2020 to 2040? What can be said about the number? Well, looks like the number of people in the workforce is going down, right? Not substantially, but it is going down. So you could say that. All right, and then D, it says, what is the maximum number of elderly men in the workforce during the period shown in the graph. Okay, the period shown on the graph is from 1950 to 2050, and all they're asking for is the maximum number right there, and that's it. So it's just learning how to read a graph and, more importantly, how to understand what the question is asking you to do. So hopefully that'll give you some help. So it looks like I've got a couple more things to go over, and then we'll be done with 1.1. So hopefully it'll just be a little short video as 1.1c that follows this one.